just make sure you guys understand exponential growth and decay on your test. You use the same formula, y equals CEKT. So first of all, you memorize this, okay? And guys, you need to study, memorize that. Okay, then you know the initial mass at time 0, your polonium is, I'll call it Y, is equal to how many grams? 200 milligrams. And then you know another time, you know the half-life, which is 140 days. Remember, time, guys, is going to be days. So Olivia, if you take the half, because this is called half-life, then you take the half of this, what will it be? Yeah, so that's the setup. This is, I guess, milligrams. And then eventually on part A, it says, find the mass present after 90 days. So it's saying T equals 90. Then they're asking, what's the mass? So guys, this will be your C. This will help you find your C. This will help you find your K. And this will help you find your answer. Okay. It's good if you can figure out how to set it up into 3 rows like that, because that's actually pretty helpful. Let's look at number 1. What did you guys get for your Y equals with your C and E, K, T, N? What did you guys get? Yeah, you're going to have to set it up on your test. Well, no, I need you to tell me the answer to part A, and then I'll do part B.
Y equals 200 E to the ln 1/2 over 140.
Okay, so like that. Okay, guys, do not use your calculator on this part, okay? Leave it as ln of 1/2, because if you use your calculator, now you've rounded the answer, and then your next answer is going to be wrong, okay? The ln 1/2 is the exact answer. And part B says, when will the mass reach 170? So what you're going to do is put your Y in for 170, or 170, and for Y, this would be ln of 1/2 divided by 140t. Okay, so we want to bring this t down to the ground. You agree with that? Trying to solve for your time. But before you do that, what do you need to get rid of? The 200. That's what students don't see. You need to get rid of the 200 first. And so to get rid of the 200, do you agree you're going to divide by 200 on both sides? So what you get is 17 over 20 is equal to E ln of 1/2 over 140t. Okay? Then, okay, I'm still trying to get that t down to the ground. Okay, so you ln both sides. Okay? See, the outer function is your E. So I'm going to take the ln of 17 over 20. On this side, I'll take the ln of E. But if you log a tree, what happens? The cat falls out. So guys, this thing falls out just like that. Okay, now what I want to do is isolate my t. So guys, what's in front of this t? Yes, yeah, so you want to get rid of this. So do you see multiply by the opposite of this? So this would be multiplied by 140 over ln of 1 over 2. But you have to do it to both sides. So this left side here, you're going to say 140 over ln of 1/2 times the ln of 17 over 20 is equal to t. Do you see how that works? Okay, and at this point, you could put it in your calculator, but be careful. You know, this is a family together. You know, this is a family together. This is dividing first, and then you multiply. So if I go to my calculator, I put up the old calculator here for those of you guys. I actually have an old calculator. So I wanted to show you guys that at one time I did buy things on sale also. And so I'm going to do 140 divided by ln of 1/2. So 140 divided by the ln. You can just put in, oh wait, I didn't put in divide. Divide by the ln. You can just put in 0.5. That saves some time. Okay, make sure you hit enter. Okay, then multiply by the ln of 17 over 20. This one you actually do have to just enter the fraction. Okay, you guys tell me if I got the right answer. Yeah, and make sure you go 3 decimal places, truncate or round correctly, whatever your test says to do. Okay, so on number 3, I'm setting up this slope field. So what I have is dy dx is equal to negative 2x over y. Okay, and so basically you just set up this chart here. X y dy dx, okay? And they put the chart for me, so I already know that my x is going to be, oh, there's a whole bunch of things. Okay, well, let's try x is -1, and my y's are going to be -2, -1, 0, 1, and 2. So let me just do this first column first. My x is -1, -1, -1, -1, -1. Okay, so what's going to be my dy dx here? Let's see. When you put in -1 and -2, you're going to get -2 times -1 over -2. So wait. No, that's right. Okay, so what I'm going to get is -1. You guys agree with that? Okay, then when I plug in -1 and -1, I'm going to get -2 times -1 over -1. So I get -2. If I plug in -1 and 0, do you see I get undefined? Right? -1 and 1, I'll get -2 times -1 over 1. So I get +2. And when I plug in -1 and 2, I'll get -2 times -1 over 2, which is 1. Okay, so your first column there is -1, -2, 2, 1. So -1, -2, 2, 1. That's your first column there. Your second column is when x equals 0. So it's the same thing, but you're going to put 0, 0, 0, 0, 0. And actually, do you see that that's, oh, wait. Yeah, how come I only have 4 rows here? I feel like I'm missing something. Oh, there's an undefined in between. Undefined, then 2, 1, thank you. And this is 0, 0, 0, 0, 0. Everybody good there? And then what about when your x is equal to 1? So put 1 here. When x is equal to 1, 1, 1, 1, 1. Uh-huh. Uh-huh. Yeah, it's going to give you a chart like this. Yeah, that's why I'm doing this review for you. Okay, so when you plug in 1, well, before we plugged in -1, so if you plugged in 1, do you see that all these signs would just change? Right? Because this would be +1, this would be +1, this would be +1, and this would be +1, right? You really just end up changing your signs. Okay, so this becomes 1, 2, undefined, -2, -1. Okay, then you just plot this slope field. Eric, are you good on this, or is it?
Yeah, I'm fine.
Okay, wait, who is it that asked the question? Was it Eric? Okay, do you want me to do the slope fields for you? Or you're good?
I'm fine with that.
Okay, you're fine. Okay, does anybody else want me to do the slope fields? You guys are good with this? So you go in and draw on your slope field. So there's actually just 1, 2, 3, 4, 5, 6. There's just 12 points you have to do. You have to just do it where the points are indicated. That's your test will be too. As a matter of fact, though, your test is multiple choice. And I just want to tell you, I know you think it's easier, but when you guys look at the answer, your eyeballs are going to fall out. Does that make sense? Because when you look at slope fields, that's just what slope fields do to eyeballs. So what you want to do, though, guys, is actually sketch some by yourself. Does that make sense? And then go match it, because that's going to make you feel a little bit less stressed. Okay. You know what? Let me just do one of these points, and I'll see. You know how you got undefined here? At what point there? You got undefined at, oh man, I don't have any of these x values here. -1, yeah, 0, 1. Oh, so undefined at 0, 0. So do you see at 0, 0, you should not put anything. So make sure there should not be anything at 0, 0. This is -2, -1, 0, 1, 2. So these are your y values. Okay, so like, oh, it's not 0, 0. Oh, sorry, then what is it? Oh, -1, 0. Okay, let me pull that out. Oops. So at -1, 0, you should have nothing. And -1, 0. Oh, but there's not even a dot there. Okay, so you don't even have to do that one. Okay. If you had like let's just do 1, -1, because that's fairly simple, but not super easy. So if we had 1, -1, you'd go to your graph here. X equals 1, y equals -1. So that you get your 2 right here. That's 1. Wait, that's not 1, -1. -1, 1, sorry. -1, 1. So your x is -1. which is this column right here, and your y is 1, so that's this value 2. And so right here, you do a slope of about 2. That makes sense to you guys? Okay. And then you just draw all your slopes. Okay. When it says a tangent line, you do the tangent line. And when it says find the solution or find then you just separate and integrate and do that. Does that make sense? When it says solve it for y or find the solution or sometimes they'll say the equation of the curve, that's all. First you separate, then you integrate. Okay. So do you want to see both C and D? Okay. C, it says find the equation of a tangent line. So we're looking at 3C. They said the equation of a tangent line. Okay, so the equation of a tangent line, you need 2 things. What 2 things do you need? Point and a slope. Okay, so guys, remember, if we're trying to find the solution of a differential equation with an equation of a tangent line, what we're really doing is the solution might be like this, but we're just grabbing a tangent line here. So we're actually approximating this red line. Okay, we're approximating it with this green line. So it's really only a good approximation right here. Does that make sense? When you go beyond, it's really not a good approximation. All right, so we're approximating right here. And, well, it's at 1, -1. So I guess we're this picture, I mean, actually 1 negative, I don't know what the picture looks like, but you guys can blow in the wind and do slope fields and stuff to figure out what the picture looks like. But let's say it looks like that. We're approximating this point here with the green line, okay? If you wanted the real value, you would use this red. If you want approximation, you'd use the green. So we're approximating. What's the point that we're looking at? Okay? What's the slope? Do we know the slope? dy dx, right? That's what the slope is. The slope of a tangent line is the derivative. All right, well, we have a formula for that, so let me put that in. And do you see, really, it's just a plug-in. Do you know what x is? Do you know what y is? Everything should be in terms of a number. So what is x, guys? Do you see just 1? What's y? Do you see where I'm pulling these numbers? So what is my slope here? 2. So write the equation of a tangent line. You can do it. Go ahead. Y minus y is equal to the slope. Ooh, my slope is 2, right? Times x minus x. And that is your answer, okay? If they say what's y equal to, then you need to subtract 1 from both sides. Yeah, you're gonna plug it into this because this is the formula for the approximation. Separate, then integrate, because that's the exact solution. Okay, that's the exact answer. Okay, so guys, right here, this would be y is equal to, and they want you to plug in, when they say f of 1.1, make sure you understand that they're asking for the y value, right? And f is always a y value. But what are they plugging in? 1.1 for your x. Does that make sense? That goes in the parentheses. So this is just everywhere you see an x, put in 1.1, and I trust you guys can do that. And that is an approximation only at that point 1, -1. Okay, so basically, again, what we did was we had some sort of blowing in the wind picture at 1, 1. Okay, and remember, there's an infinite number of blowing in the wind pictures, right? But we're looking at the one at 1, 1, and then what we're doing is we're making a tangent line right there. And that tangent, this is obviously not right because it's a positive slope, but this is just an example. So that tangent line right there, you're saying what is the value right there as an approximation? And you can see that the approximation will always be bigger or smaller than the real in this picture. Well, I don't know what, actually, I'm not drawing this picture correctly, so we don't know for sure. But if the second derivative is positive, the approximation is going to be lower. If the second derivative is negative, then the approximation will be higher, okay, than the real value. If you ever have, so for a simple problem, which I know you guys know, but for a simple problem, if I have x squared equals to 9, okay, if I ever square root anything with a squared in it, and I'm trying to solve it, then the other side gets a plus or minus. The other side gets a plus or minus. If I ever solve something, you know, like this, I don't know if this is right, but if I solve something like this doesn't have a squared in it, right? So I don't get a plus or minus, okay? I don't get a plus or minus. But if I ever square root something with the squared, the other side gets a plus or minus. That's how you do it. So I think this problem, I mean, I can do it fairly quickly. I think you get, do you have like y squared over 2 is equal to negative x squared? Did you get that? Okay. Then what you'd do is you'd say, Okay, did you solve for y first, or did you solve for c first? Okay, so if you solve for c first, you have your initial condition, which is x is equal to 1 when y is equal to -1, right? So this would be plug in -1 here. Okay, be careful. -1 squared is not negative, right? -1 times -1 is +1. If you plug in 1 here, you get -1 plus c. So did you get your c was equal to 1.5 or 3/2?
Yeah.
Okay, or 1.5. Okay, so that means you come up here and you put in 3/2. Okay, and then what you want to do is this basically is your answer. You just need to solve for y, but this is basically your answer. So how are you guys going to get rid of this 2 and get rid of the square root? What are you going to do? Okay, yeah, how about we multiply by 2 first? Just one step at a time. So multiply by 2 first. So you get y squared equals -2x squared plus 3. You with me so far? But do you see when you square root this, you're going to get a plus or minus because you're square rooting a y squared. Okay, so if I square root this and square root this would be y, but the plus or minus ends up on the other side. So this will be plus or minus the square root of -2x squared plus 3. And then this is basically your answer, but actually you have 2 answers here, and only sometimes both are the answer, but sometimes only one is answer. Do you see that there are 2 possible answers here, guys? You see there are 2 possible answers? Okay, well, which one is it? Well, it's going to be the one where when you plug in x equals 1, you get -1. Okay, and if I plug in x equals 1 here, I'll get +1. If I plug in x equals x equals 1 here, I'll get -1. Do you see that? So that's why this is the answer, but not this. You had 2 choices, okay? If they both satisfy this condition, then both of them would be the answer. But it turns out only one of them satisfies this condition. So guys, this problem right here, we're looking at number 8 on your review. When you know when x is equal to 2, y is equal to -3, and this is number 8 on your review. Okay, first you separate, okay? So first, let's separate. When you separated, did you get the same thing as I got? You got divide by y on both sides. Then you integrate. Sometimes you exponentiate. Do you need to exponentiate here? Well, actually, let me integrate first. ln of y plus c is equal to x cubed plus c, but I only need c on one side. Okay, do I need to exponentiate for this problem? Yes, so I'm going to exponentiate just means put a big E. When you tree a log, or when you log a tree, what happens is the cat falls out. So y falls out. But on this side, and I hope you're okay with this, you can say c e x to the third. And this c is actually different from this c, so I'll call that c1. Okay? And I'm going to box this in because, guys, this is your answer. You have to understand, I was told to solve for y. This is your answer. It's just that I need to solve for c. But whatever my answer is, it's this answer, but you just put c in. Okay, so make sure you understand that, because when we start plugging things in, you forget that this was your answer to begin with. Okay, so all we need to do is plug in c. And to find c, you need your initial condition. So now I'm going to find out what c is, but everywhere there's a y, I'm going to plug in -3. Everywhere there's an x, I'm going to plug in 2, right? Now, how do I solve for c? How do I isolate the c here? Just think of algebra. That's it. Algebra 1. Divide by what on both sides? E to the 8th. And those of you guys who are who love your calculator, this is going to give you problems on the calculator. So I do not recommend the calculator addiction, okay? Because e to the 8 is huge. Your calculator is going to make it huge. When you divide by 1, your calculator is going to make it super small. So it's a lot better just to work with e to the 8, because that's an exact number anyway. So what happens is, do you see this is what your c is? Okay, so then students have trouble here, but guys, all you do is you know your c, you know your y, right? You just put c into your y. So y is equal to -3 over e to the 8 times e to the x third. And that is your answer. If you leave your answer like this, I will count it right. I will probably have to, though, It probably, my math lab probably won't take this answer, but I will count it right. I'll look at your worksheet, I'll look at your work, and I'll see that that's the answer, okay? But what I need to tell you is that this is an unsimplified answer. Why? Because if you had x over 7, x to the 7 over x to the 5th, what is the answer to that really if you simplify it? X squared. What did you do with the 7 and the 5? Subtract. Okay, so do you see that this is really over 1, right? So this is really, I could move the e8 over here. So this is negative 3 times e to the x third over e to the 8. So using this same principle over here, what is this fraction really? E to the x third minus 8. And that is a simplified answer. Okay, and that's probably what my math lab wants. So we'll do it again. Also, your shirts, they've kind of run into a problem because those colors we have, they don't have. So we're trying to change up the colors and still make it look good. Okay. So here we are. Okay. First you separate. You guys good with that? First you separate. Then you what? Integrate. So I'm going to integrate both sides. On the left side, you cannot actually do U substitution here. Well, it's not U substitution, but you can't do ln. Because if you said this is an ln, you take the derivative of this entire bottom, which is y to the 1/2. So the derivative of that is 1/2 y to the negative 1/2. So then you, which is really, to simplify, it'd be really 1 over 2 squared root of y if you took the derivative of that. So let me just make sure. If you take the derivative, that's what you get. And if you divide this by 1 over 2 squared root of y, do you see your y's don't cancel out? Okay, it's not an ln problem. Just because you have a denominator doesn't mean it's an ln problem. You have to take the derivative and divide by the derivative, and all your x's have to cancel out, and it doesn't always happen. Okay, so what you do here is you say, I'm going to move the y up. But be careful, guys. A lot of people move the y up, and this is what they get. What did I do wrong? Yeah, it's negative. It's positive 1/2 down here, but when you move it up, it's negative. So what you get here on the left side is you add 1, divide by 1/2, but dividing by 1/2 is the same as what? Multiplying by 2. So what I get is 2y to the 1/2 plus c on the left side, which is really 2 square root of y, guys, if you wanted to say that. And are you guys okay if I move the c's to the right side? Okay, let's go to the right side here. What is the integral of x plus 5? Oh boy, do you feel it welling up inside of you? You thought you got to do one problem, but really, guys, you get to do 2. Okay, check that out. So this is going to be x squared over 2 plus 5x plus c. Do you see how that works? It's not a u sub just because it has parentheses. This really is just 2 different problems. So what I get here is, maybe I should put it down here, x squared over 2 plus 5x plus c. Okay. What is my goal? Solve for y or solve for c? What do you want to solve for first, y or c? Y. Okay. So to solve for y, let's first get rid of this 2. So that's going to be divide everything by 2. But guys, if you take c and you divide it by 2, just c, yeah, it's just still another c. So I'm going to call that c, but this c is going to be a different c from all the other c's I had before. Okay? Then how do you solve for this y? You square it. So guys, be careful. You cannot distribute a square. You can't square this and square this and square that. That's not how you square. You square both sides. That means you square this side and you also square this side. You square the whole thing, okay? Because these are families, okay? So when you square this whole thing, you actually can't even move beyond this. This is it, guys. You just square it and that's your answer. Okay, that's your y. How do I solve for c? How do I solve for c? Do I have an initial condition somewhere? What is it? When x is 2, y is 9, is that right? Okay, so let's go ahead and plug in. Whenever x is 2, y is 9. So this is going to be 9 is equal to 4 over 4 plus 5, because that's 2, right? 5 halves times 2, plus c, quantity squared. Okay, how in the world do I solve for c here? How can I get this, isolate this c? Is everybody good with that? You got to get rid of that squared first, because that's like the outside function. Okay, so guys, make sure you understand, since this is a squared, this is plus or minus. So what I get is plus or minus 3 is equal to 4 over 4 is just 1. Oh yeah, just 6 plus c, right? I heard you say that, but I wasn't paying attention. Okay, 6 plus c, right? So do you guys see there's two answers here? You could get 3 is equal to 6 plus c, or you could get negative 3 is equal to 6 plus c. So what's c going to be on this side? What's c going to be on this side? 9. Okay, so these are your two possible answers for c. So come up here. Okay, when you had your y here, this is your answer for y. It's just that c could be, now I forgot, 6 or negative 9, something like that. Oh no, negative 3 or 9. So this could be negative 3. So c could be negative 3 or c could be 9. Did I do that right, guys? This right here should be negative 9. Thanks. Okay, so c should be negative 3 or c should be negative 9. Okay, so right. So 9 is equal to, the x here is 2. You're right. So it should be 2 squared over 4 plus 5 halves. This should be a 2. Oh, that's much better. Okay. I'm sorry. This should be a c, but these x's should be 2's. Okay. Now I don't have to use a calculator. So now I get 9 is equal to 1 plus 5 minus 3 squared. Is that equal to 9, guys? 6 minus 3? Yes, so that's a check. So c is actually equal to negative 3. Let's try the c equal to negative 9. Okay, so that would be, let me move this over. This is for c is negative 3. Okay, and in blue, I'll do the, so this is for the negative 3. And in blue, I think it's blue. Okay, I'll do then c is negative 9. So that means y is equal to, okay, my x though is 2. So that's going to be 4 over 4 minus 5 halves. My x is 2. So that's going to be 2 minus 9 squared. Okay, and what I want to do is I want to see if this is y is 9. So this will be 1 minus 5 minus 9 squared. Does that give me 9? No. So this is not an answer here. Okay. Because 9, yeah, that's not going to give me 9. Okay, so then my answer is y is equal to x squared over 4 plus 5 halves x minus 3, and then you square all that. You just plug in your c, and that is my answer. So 11 is x integral x secant x squared tangent x squared dx. All right. I'm going to make my u equal to x squared. Oops, this didn't have an x in the front. Sorry. Okay, I'm going to make my u equal to x squared. That's because it's parentheses. You're only allowed to have 2 u's, guys, if you have a secant u, tangent u in your formula sheet. Does that make sense? If in your formula sheet you have 2 u's, then you can have 2 u's here. Otherwise, you can't have 2 u's. All right, so you see this is going to be u, and this is going to be u also. Okay, so first you find your u, then you take the derivative, and so that's going to be 2x. Then you solve for dx. Okay? Then you substitute 2 things. What 2 things do I substitute? My u and my dx. But this problem will actually have 2 u's, just because there is actually a antiderivative on my formula sheet that says secant u, tangent u. Okay? So then you rewrite this. So this is secant u, tangent u times du over 2x. And the question is, do my x's cancel out? Do they? Why, yes, they do. Do you guys think that on your test? Do you think, why, yes, they do? Okay, so then what you do is you look at this and you say, is this on my formula sheet, or is this an easy antiderivative? It is on my formula sheet, but what would make it even better on my formula sheet? pull out the 1/2. Okay, that would make things a lot easier for you. So pull out your scalars before you actually do your formula sheet. And guys, on your formula sheet, what is the integral of secant u tangent u? What is it? Secant u plus Charlie. And is there a negative in front or not? No, that's because this S doesn't start with a C, okay? So that is my answer. It's a great answer, okay? It's just the wrong answer. What do you need to do? Go back and put in u. Make sure you pick the right thing as your u. My u is x squared, so that is the right answer. The u substitution, I'm actually not going to do the exact problem for 13. I'm going to make up a similar problem because I want you guys to practice yourself. But let's say I had a problem like this. Let me just put another number here. Actually, I should make this like 2x cubed. Yeah, there you go. Okay, so this is 13, but it's a harder problem than 13, but you do it the same way. Okay, so guys, if you want to know the integral of this, okay, first what you do is you figure out your u. So what's my u in this problem? 5 plus 2x cubed. What's the derivative of this going to be? You see, first you find your u, then you take the derivative, then what do you solve for? Dx. Okay, it's the same, it's going to be the exact same process as number 13. Okay, so first you find your u, then you take the derivative, then you solve for dx. Then you substitute two things. What two things am I going to substitute? My u and my dx. So this becomes a rewrite. Okay, but if you don't circle it, like I didn't circle the square root, okay, then you have to put it back. All right, this right here is du over 6x squared. Oh, this is x squared, sorry. Okay, so the integral, if it didn't circle it, you need to leave it back. But if you circled it, then you can substitute your u and your dx. So this is my u right here, and there's my dx right there. Those are the two things you substitute in. And then you ask yourself the question, and for you guys, this will always be true. Do my x's cancel out? Why, yes, they do, okay? And so this will be 1, and then you rewrite this problem, so you get 1 over square root of u times du over 6. And at this point, you should have an easy antiderivative or something on your formula sheet. The problem is it doesn't look easy because of what? Do you see what you could pull out? Pull out the scalar. What is it? The 6, yeah. So when you pull it out, you're going to pull out 1/6 the integral of 1 square root of u du. Now, is this an easy antiderivative, or is this on my formula sheet? If it were 1 over u, it would be on my formula sheet. Do you see that? Okay, it is an easy antiderivative. So be careful. I do see that a lot of students would think this is an ln problem. The reason it's not an ln problem is because when you make this your, remember this is u to the 1/2. So when you make this your u, the derivative of this will be 1/2 u to the negative 1/2, and it's not going to cancel over here. Do you remember you have to divide the numerator by this, and it doesn't cancel, okay? So only cancels if you have just a plain u down there. All right, so it's an easy antiderivative. Okay, just telling me it's an easy antiderivative doesn't make it easy. Okay, so what do I need to do to make it an easy antiderivative? Move it, like rewrite it. Okay, when you rewrite it, now it is an easy antiderivative, and you add 1, divide by the new exponent. What's the new exponent there? Yeah, it's 1/2, but then if you divide by 1/2, you really multiply by 2. So I'm going to multiply this by 2. So this becomes 2 times 1/6, which is really 1/3 u to the 1/2, and don't forget Charlie. And that is a great answer. But it is the wrong answer, okay? You need to come back in and put in your u, whatever it is, just put it in. And guys, please don't put in like the wrong u. Like some people come up here and they'll put in 6x squared. Seriously, you did all this work. Don't waste it by putting in the wrong u, okay? And there is the right answer. A prettier way to do it would be to actually move this to the square root of 5 plus 2x cubed, but you don't have to. It's just a prettier way to write it. So both of these answers are acceptable. Okay, so this is not your answer, but your number 13 is similar to it. Same problem. I'm going to do it like this. It's the same problem. Okay, what you do is you set your u equal to usually your parentheses. Then you do the derivative of both sides. Then you solve for dx. Okay, this is not your exact problem, but it's similar to 14. Okay, so first you find your u, then you take the derivative, and then you solve for dx. Then you substitute two things. You substitute your u and you substitute your dx. So that will give me, okay, if you don't circle it, you're not going to substitute it, okay? Then you ask yourself the question, do your x's cancel out? Why, yes, they do. And so then what you have left is u3 over 3 du. But this is really hard to work out. So do you remember we pulled out all of our scalars first? Okay. And then you say, is this an easy antiderivative or something on my formula sheet? It is an easy antiderivative. You add 1, divide by 4. This is 1/3 times u to the 4 over 4 plus c. Okay, so guys, then you put the u back in. Okay, and this is an answer to a similar problem. Your answers will be similar, but not exactly. Okay, so this is the limit as h goes to 0 of f, tangent of x plus, oops, yeah, I'm writing this other formula, plus h, and then minus 1 over h. Okay, what does this look like, guys? The definition of a what? A derivative. So guys, please make sure that you say this is equal to f prime. It is not equal to f. That's the number one thing students do wrong. They say it's equal to f. We would never learn the definition of a function in here. Do you guys know the definition of a function? Me neither. We never learned it in here, okay? It's a definition of a derivative, okay? Now, remember, the real definition of a derivative, the formula is this. Oops, minus f of x over h. And you should memorize this, okay? And this is why you should memorize it. The reason you should memorize it is because if you compare these, do you see, you could actually figure out what your x is equal to. Do you see that? That's x is equal to pi over 4. So really what they want you to do here is figure this out and then plug in x equals pi over 4, okay? You know that because this x is in that right place, and your problems will always be like that. The other thing you need to figure out is pull out your f of x. We've asked you to do this before. Pull out your f of x. And the secret to that is before, when you made your f of x plus h, you started out with an x, and then you put in x plus h. So the old x used to be whatever was in your parentheses. So whatever you make this parentheses x basically. And so guys, this is always your f of x. That's the secret. Okay, pull out your f of x. And the secret to doing that is the new x plus h used to be an x. Okay, see if this makes sense. Like if this was f of x, if I wanted f of x plus h, wouldn't you, everywhere there's an x, wouldn't you put x plus h? So that would be tangent of x plus h. And then if I knew that my x were equal to pi over 4, wouldn't that be equal to tangent of pi over 4 plus h, right? So somehow you need to understand that when you have this and you need to go backwards, you need to be able to get this, okay? So that's the first thing that you should be able to do. And really all it is, guys, is find your first parentheses, put in an x. That is really all you have to do. It should be something plus h, okay? Then what you do is you don't want to know what f of x is. Is this the definition of a function? No, it's the definition of a derivative. So guys, if I know what f of x is, what's your derivative? Right? The derivative of tangent is secant squared. Okay. Then once you know that, I don't want to know f prime of x. I want to know f prime of x when x is pi over 4. So then what you do is everywhere there's an x, you put in pi over 4. And if you stopped here on your answer, I would say, good job, Ryan, minus 1. Okay. Yeah, he'd probably stop there. Okay. No, this is actually a great place to stop. But you know, you could actually calculate this. First of all, you have your calculator, but the problem is your calculator doesn't do secant. So you do have to understand that this, if you wanted that extra 1 point, if you didn't want a 99 on your test, Ryan, and you wanted 100 instead, okay, what you would do is you would say secant squared pi is actually equal to, pi over 4 is actually equal to secant squared, right? Do you understand that? But that is actually equal to secant pi over 4 times secant pi over 4. Do you understand that? But there is no secant button on my calculator, okay? And while that bothers me a lot, I actually don't want any more buttons on my calculator. And I bought my calculator on sale, so for sure, it probably wouldn't work anyway. So what is secant really? Do you remember? Secant x is really 1 over what? Cosine x. And cosine is actually on my calculator. Okay, so this is actually equal to, and you just copy this. This is secant pi over 4, and this will be cosine pi over 4. So you're going to say this is equal to 1 over cosine pi over 4 times 1 over cosine pi over 4. Okay, and even though you can do this on your calculator, at this point, I just want to show you it's actually not very hard here. If you can get it to this, you're pretty much good. What's the cosine of pi over 4 on your unit circle? Okay, square root of 2 over 2 times 1 over square root of 2 over 2. 1 times 1 is just 1. Square root of 2 over square root of 2, or square root of 2 over 2 divided by square root of 2 over 2. Isn't that square root of 4 over 4? Well, isn't that really 2 over 4, right? But what's 2 over 4 really? 1/2. And so guys, what's 1 over 1/2? 2. So all that work and the answer was just 2. Okay, so this answer, if you put this, you'll get just minus 1 point. And if you put 2, guess what you'll get? A 100. Okay. All right, so do that for the second problem or the last problem too, guys. And the last problem is even easier than this one. And the one on your test is going to be more like the last problem.